Dear students, today we are going to see an important topic in the machine learning, that is data transformation, and that is data cleaning. Okay, so mainly we are going for data cleaning. Okay, so let us see PPT in a full screen. Okay, so data transformation is the process of converting the data from one format or structure into the another format or the structure, right? Okay. So mainly, we are going to use this data transformation for converting the data from one format, right? So data cleaning mainly, we will integrate, or sometimes, okay, from the different sources, and how we are going to use the data for the future. So smoothing is one of the process which removes the noise from the data. Techniques that is include binning, regression, and clustering. We are in this first we are removing the noise from the data. That is called the smoothing. Okay, and then attribute construction or feature construction, where new attributes are constructed and added from the given set of attributes to help the mining process. That is actually called the attribute construction, and then aggregation. So here we are grouping together. So that means the summary or aggregation operation are applied to the data. This type is typically used in constructing a data cube for data analysis at multiple abstraction levels. Okay, so that is the time we are going to use here. And then normalization. Sometimes, so for example, if there is a age is 25 as a fresh employee, and the salary may be uh, okay, so it may be 60,000 or 70,000 something, right? So when you compare this value, so here 20 and there 70,000. Likewise, only the system will check. So we have to go for normalization. Okay, this is the range means we will have this value. Like that, we are going to normalize the input variable. So we can sort the issue. This is also one of the process of data cleaning. Okay, then we will go for discrimination. Discrimination, that means the raw value of a numerical attributes. Example, age are replaced by interval labels, that is 0 to 10. That is the time what is the attitude, and then 11 to 20. Likewise, we can give some range, okay, to express and to get a clear understanding, right, about the person. And then concept hierarchy generation for the nominal data. Okay, so here where attributes such as a street can be generalized into higher level concepts like city or country. Okay, so mainly begins with the street, and we can go even up to city and country when we do the data analysis cleanly. Okay, so mainly normalization, as we discussed, depends upon the two numerical value. We are going to normalize it. Okay, so we will study min max normalization, set score normalization, normalization by decimal scaling. These are some of the ways we can normalize the thing. Okay, so normalization is a very important concept in the data cleaning process of machine learning, right? Okay, and then now we are going to say about the min max normalization. Okay, how we are going to calculate this min max if we are having like a VI, that is a min max normalization maps a value, right? VI of A to VI dash in the range new min, okay, and then new max by computing. How we are going to computing the value of VI, okay, dash. We can see that VI, okay, that is the value which is the input, and then minimal value, that is min of A divided by max of A. Okay, so that is how we know the maximum and minimum value in which we are going to apply. And then here, new max A, and then minus new min A plus new min A. This is how we are calculating it. Okay. Suppose that the minimum and maximum value for the attribute income, or these are the things respectively, we would map to range 0 to 1. Okay, so that is the thing how we are going to do by min-max normalization. The value of 73 $73,600 for income is transferred to how we are going to do 73,600, that is the input we are given, and minus 12,000 divided by 98,000. Okay, so minus 12,000. So this is how we are normalizing the value, right? So 1.0 minus 0 plus 0. So we are getting minus 0.716, or otherwise in the above example, if you are not normalized it completely, the value will be uh, very tough to find out, right? So that's why this normalization will help us. Okay, so these are some of the different categories of normalization. Okay, already we have seen in the data science as well. Okay, in the previous section itself. So I'm going about these are the steps like formula we have to apply for it. Okay, so and then we are calculating the normalization. Okay, and again we are going to see about the data transformation. Okay, so data transformation, that means it is like a continuous data into the smaller. Okay, so smaller interval. Okay, so continuous data into the smaller interval. So mainly we are transforms the numerical data. Okay, so by mapping the values to the interval or concept labels. Okay, so mainly the transformation is like break up the continuous data into the smaller intervals. Okay, so for example, here after discretization, okay, you can see that the age which belongs to this particular group, that can be grouped together and we can say that is the child age, okay, and then young age, and then age from 30 to 46, something we can say it as like mature, and then age which is okay, so 70, 74, 77, 78, and all, we can say that is old, right? Okay. So we are finding the age and depends upon the different data points we are grouped together and then we are giving the result out of it. Okay. So this is the like a data transformation. Okay. What is this discretization by binning? That is a top-down splitting. Okay, so data smoothing, as you know, it is like okay, top-down splitting technique. So here the attribute value can be discretized by applying the equal width or median. Okay, how we are going to calculate the mean, median, okay, and then how we are going to calculate standard deviation, variance, and so on. So there is a definite formula for it. Okay, how we are going to do it. Okay, this binning does not use class information. So we can say it is an unsupervised discretization technique. Okay. So for example, if we are having this for histogram analysis, okay, so here we can have like equal width histogram and equal frequency histogram, how we can calculate. Okay. So here the values are partitioned into the equal size partition of the range. Okay, so that is how we are calculating this equal width histogram, which is denoted by W, which is equal to H minus L by NP. Okay, highest value minus lowest value by NP value, right? So in which we are getting the equal width. Similarly, equal frequency histogram. Okay, all these things they are calculating. Okay, so coming here, we can see that this is an example in which the data points which is given, in which we are going to find the equal width. That means bin we are going to have like one that is 0 and 4, that range. Bin 2, that is 12 to 18 range. And then bin 3 is 24 to 28 range. Okay, so that is how we are just to group together first to find the equal width. And then equal frequency we are calculating. That means bin 1, okay, that is we can say that 0, 4, and 12. And bin 2, 16, 16, and 18. Bin 3, we can say in terms of values. There we have just to talk in terms of the thing. Okay, so here we are talking in terms of the values. Okay, and then we can go for the discrimination by cluster. Okay, cluster. Okay, how we are going to do here also we are grouping together based upon the okay features, okay, how it is connected with one another. So, for example, clustering algorithm can be also used to generate a concept hierarchy. Okay, for A, by following either a top-down splitting strategy or bottom-up splitting, merging. Okay, so bottom means one after another grouping, and then we are going to the top level by grouping together. Okay, but top down means it will have everything. So we are going to classify and then we are going to remove something. Okay, so that's why we can say this is top down and this is bottom up, right? And then decision tree, right? Okay, mainly we are calculated by means of the entropy value, okay, in which we are going to calculate the root node, child node, and the right node and left node, and keep on it progress, right? Okay, so these are some of the measures of the correlation. Okay, so chi-merge we have seen, right, in the lab in data science itself. Chi-merge is supervised in that it uses the class information. Okay, and then we can see that merging is also can be done. Okay, if you are getting the input from the various sources, how we are going to handle. Okay, so here we have a top-down mapping and bottom-up mapping. What is this top-down mapping? We can see that top-down mapping often begins with the basic information. Okay, so at the top. So that is how actually we are having here. Okay, so that is the basic operation, right? Okay, right. So based upon the entropy we are calculated, and then here based upon the okay, so concept hierarchy generation mainly, okay, so it defines the sequence of mapping. Okay, so from the set of the low level concepts to the high level. Okay, so mainly it starts from the low level concepts to the high level. It will be more general concepts. Okay, so top down mapping, you can see here often it begins with basic information at the top. Okay, so general, like all, and then region, and then coming to the country, and then city, and then to the office level. So when you dig on to the decision tree, you can see, okay, when you go to the bottom, only the specialized information you will get it. That is actually called the top down. Okay, and coming to the bottom up, so at the bottom with specialized data and finishes at the top with more generalized data. Okay, so that is how we are going for the hierarchical generation, right? So I hope you understood about the data transformation part. And also there are different categories of data cleaning. Okay, so that we will see in the next PPTs, right? Thank you.